Good morning, everyone. Welcome back to math class with me, Mr. Didymus Santoso. Today, we are going to cover geometrical properties of circle. Now, there are five items that we are going to cover for geometrical properties of circle. There are chord properties, tangent and radii properties, angle properties, the cyclic quadrilateral, and segments. But for today, we are going to cover only two items. There are chord and the tangent and radii properties. Now, before we move on, to really dive into this topic, I want to make sure that everyone understand all the components of circle first. Okay, so I have here a blank or blind name for every components of circles, and I want you to write down all the names for the green area here, the red line here, and then also the blue line, okay, that cut through the circle, the purple line along this part of the circumference of the circle, and also this yellow line. Okay, these are two things, they have different names. Okay, the yellow and the blue have different names. Okay, and then the orange one. But also I want you to name recall the name of the area enclosed between blue and the purple lines. Okay, so I give you 5 minutes to write down on your own notes. Okay, and then later we will each one of us will say what it is. Okay, all right, so we have the green one as minor sector. Okay, the red one here is radius, the blue one is chord, the purple one here is called arc, the yellow that cut through the circle, okay, it's called secant, and then the orange one is called tangent. It only touches the circle at one point. Okay, and then the area that is enclosed by chord and arc is called minor segment. Okay, so if we have a minor segment here, that means the other part, okay, that is covered by the other arc and the other side of the chord is called major segment. Okay, so we will use a lot of this term when we cover the geometrical properties of circle. Now, the first one that we are going to cover is the first property of chord. Okay, so I want everybody to prepare a piece of paper, pencil, ruler, a compass, and a protractor. Okay, so if you don't have it with you, I give you 1 minute right now to get all your items, okay, before I proceed. Okay, so 1 minute. Now, everybody already have their paper, pencil, ruler, compass, and protractor. All right, so we are going to draw 3 circles, okay, with center O1, O2, and O3. So I'm going to draw over here 3 circles. Actually, we can just draw 2 for now. Okay. And then I'm going to call this O1. Okay, and this one here is O2. Okay, and we want to draw a chord in each of the circle. Okay, so I'm going to draw a chord. At any size. All right, is everyone done? Okay, let's continue. Now, for the first one, okay, for O1 here, we are going to draw a middle point on chord C, this chord AB. Okay, so let's not confuse this. I'm going to rename this with C1. Okay. And then the other one is D1. Okay, so let's draw a midpoint, okay, on C1 and D1. You know how to do it, right? So you measure it and you divide by 2. Okay, so this is my midpoint, and I'm going to call this midpoint M. Okay, M1. And then next one, we want to draw a perpendicular line. Oops. Perpendicular line, okay, of CD on the middle point. Okay. Okay, so it's a perpendicular line on M1. Okay, it's perpendicular to CD. So how do I check on this one? Okay, just making sure that it's perpendicular. See? Okay, so it's perpendicular right there. Yeah. Now, what do you notice here? Okay, what do you notice here with the line? That's right. So it meets, the line meets the center of the circle. Okay, so let's move on to the second observation with our second circle here. Okay, so this one I'm going to call it C2. Okay, and then this one here is D2. Okay, so we want to draw a middle point on chord CD. Okay, middle point on chord CD right here. Okay, and then we want to connect the center of the circle and the middle point of CD. Okay, so this middle point, let's call it M2. Okay, and we want to connect, draw the line. All right, now from here, what do you notice? What can you, what kind of conclusion can you get from here? Okay, so if we check on the angle, okay, it is actually 90 degrees, so it's perpendicular. Okay, so from these two observations, okay, we can also say, right, without looking at the third observation, is that if a line, okay, that is passes the center, okay, and is perpendicular, okay, the line passes through the center and is perpendicular to the chord, it will actually divide the line into two equal parts, or in a simple word, it's called bisecting. Okay, so the line will bisect the chord, okay, into two equal parts if they are perpendicular. Okay, so in general, we have all these three items that if we have these two information, either of the three, we can assume, we can come to the last conclusion. So for example, if we say we are given that, okay, so there's a line passes through the center, okay, and it bisects the chord, okay, then it's perpendicular. These two lines are perpendicular, okay. Or if we know that there's a line bisecting the chord, okay, BC here, and it's perpendicular, okay, these two lines perpendicular, that means this perpendicular line will pass through the center, okay? And then if we have a line that passes the center and is perpendicular to the chord, we can say that they are bisecting the chord, okay? Any question at this point? Is everyone clear? Okay, so let's continue to the second property, okay? So again, on a piece of paper that you already have, okay, I don't want you to reuse the circle. So draw another circle with center O, okay, and then draw two equal length chords on the circle. Okay, so I'm going to create a new one here. So I have a circle and then I have two chords. Okay, let's say okay, so I have two chords, the same length, okay, anywhere on the circle, okay, and then we want to label the end of the chords, okay. Now it's always good to put labels on your points, okay, but the circle usually we call it center O, okay. And then so this one is chord BC, this one is chord DE. Now we want to draw draw a line to indicate the shortest distance from the center of the circle O, okay. What do you think is the shortest distance? Okay, so if I draw a line from here to here, is this the shortest? Maybe not, okay, but as I go closer and closer here, okay, this could be the shortest, okay. Same with the other one, okay. Okay, let's try. This is the shortest, okay. And then let's measure the distance from center O to the chord, okay. And what do you say about the length of the distance? So try to measure the length of OA and OF here, okay. Actually, this is kind of confusing, right? So I'm going to change that to M and this one to N, okay. Okay, so this one is M, N, okay, and this one is M. All right, so what is the distance? Okay, so if I use this one, okay, so I got 2.51, and then this one here is 2.52. They're pretty close, okay. So the shortest distance from the chord to center O, okay, is actually perpendicular line, okay. That will be the closest, okay. And if you get a perpendicular line, okay, then okay, you can say the distance actually the same, right? Okay, it's very minor difference here, okay, but if you draw it accurately, okay, so if you want me to draw this accurately, okay, so my M right there, okay, delete this one, and then my N is actually pretty accurate, okay. I'm going to measure this again, yeah, just to make sure that they are equal, okay. Okay, So it's, I don't know why this still give me a different number, but they are 2.5 and in length. Okay. So how do you describe this situation? When the chord BC and DE are equal, okay, what do we get here about the distance? They are equal in distance, okay. Maybe we can shorten them up, okay. So the equal chords are equidistant from the center, okay. All right. So how do we prove this? So we can prove that this triangle, okay, please look at the circle here, okay, so we can prove that ABO, okay, that and the triangle CDO are congruent, okay, and thus the perpendicular height is the same, okay. So we want to prove that. How do we prove it? Okay. Just before I confuse everyone here, I'm just going to rename, okay, here, okay. So we look at the triangle ABO and then CDO, okay. So we are given that AB equals to CD, so AB equals to CD, right? The chords are equal in length, and then OA equals to OC, okay, and they are radius. Similarly, to the other side, also OB and OD, they are radius, so they are equal in length. So we can conclude that triangle ABO and CDO are congruent, okay, with the side test. So the perpendicular height is also the same, OM equals to ON. All right. Any question at this point? No? All right. So let's continue with the conclusion. So in general, equal chords of a circle, so equal chords of a circle are equidistant from the center of the circle. Okay. And then chords that are equidistant from the center, so this chords and that chord, okay, we don't know the length yet, but if they are equidistant, that means they're equal in length, the distance, okay, from the center of the circle. Okay, so the length of the chord are equal. Okay. All right, so let's take a look at an example, okay, for some problem related to the first and the second properties. Okay, so in the figure AB and PQ are chords of a circle with center O. The point M lies on AB such that OM is perpendicular to AB. Okay, and the point N lies on PQ such that ON is perpendicular to PQ. So this is the visual, consider drawing of what is explained here. Now, given that AB equals to 12 centimeters, OM, okay, is 7 centimeters, ON is equals to 4 centimeters, find the length of the chord PQ, giving your answer correct to 2 decimal places. All right, so how are we going to solve this one? Now, the first one, okay, wait, up here. Okay, so the first one, OM bisect AB. Okay, OM bisect AB, right? So that's from the first property. Okay, so we can say AM equals to MB. That means this 12 divided by 2, right? So AM is 6, MB is 6. Now we want to consider the triangle OMA. OMA. Okay, we can use Pythagoras theorem. Okay, so OA square equals to AM square plus OM square equals to 6 square plus 7 square equals to 85. Okay, since OA equals to OP, okay, then OP square also 85. Oh, sorry, OP square is also 85, right? Now we have 85 here. Now we want to consider the other triangle, okay, OPN, ONP. Okay, so OP equals to ON plus PN. that correct? Not really. Okay, so it's OP square equals to ON square plus PN square. So, okay, Pythagoras theorem. Now OA, okay, so just everyone can see this triangle. Okay, there you go. Now OA is 85, okay, equals to, since OP square equals to OA square, so we can say OA square equals to the 4 square plus PN square, which is 85 equals to 16 plus PN square, okay, and then PN equals to 85 minus 16 equals to 69. So PN here is square root of 69. Now ON bisects PQ, right, from the first property. And so PQ is 2 times PN. So PQ is 2 times PN. That means 2 times square root of 69. Okay. And if we convert that into decimals, okay, it becomes 16.61 centimeters. Okay, 2 decimal points. All right. Next example. The lengths of 2 parallel chords of a circle of radius 12 are 8 centimeters and 14 centimeters respectively. Find the distance between the chord. Okay, so I give you some sketch here, what it might look like. So these two lines, okay, they are parallel, okay, and this one is 8 centimeters, and the other chord is 14 centimeters in length with the radius 12 centimeters. Okay. How do we solve this problem? We want to find the distance, right? The distance between the two chords. Now, the chords are on the opposite sides of the center O. Okay, so this is the first case. There could be another case, and can anyone guess what it is? Correct, that these two triangles are on the same side. Okay, but let's look at this first case where they are on the opposite sides of the center O. Okay, in triangle AON, okay, we can get ON, okay, because we know these two lines are line AB is bisected by ON, right? So it's AN is 2 and then OA is 12, so we can get ON using Pythagoras theorem. So ON is 11.31. Okay, and then in the triangle YON, okay, YON, we can get OM, okay, which is equals to 9.747 using Pythagoras theorem. So we want to find the distance between the chord MN. We need to add them up, right? We need to add them up, and it comes 21.1 centimeter. Okay, and then the case 2, which is again it's on the same side of center O. Okay, we already know from the previous case that the length of ON is 11.31 and OM is 9.747, but we need to find the distance, okay, of MN, the distance between MN. So it's ON minus OM equals to 1.56. So the distance can have two answers that are either 21.1 or 1.56. All right. Any questions here? If no questions, then we can go for exercise time.